My turn.
Oh, you won again, Shane. What can I say?
Better luck next time. Alright, we're group 4.
And we're the Checkerless Checkerboard team.
My name's Shane from Minalga.
And I'm Brandon Kaibura.
This is the Checkerless Checkerboard. The goal of our project was to remove the pieces from your standard checker game in order to make it easier to play and more kid-friendly. This is our block diagram, isn't it?
Yes, it is, Shane. In fact, I think it's best to explain it from the top down.
Okay, well first we have the power supply, which rectifies an AC source to a 12-volt DC voltage that is sent to the step-down block, and then the step-down block drops the DC voltage to 5 volts to be dispersed to the microcontroller, RGB LED grid, and the button grid.
Next, we have the microcontroller at the center of our project. It receives power from the step-down block. It also receives button press inputs from the players and sends that data back to the microcontroller. Lastly, the microcontroller takes the data received from the button presses, converts it to a set of directions for the RGB LED grid, and then sends those directions to the grid so that it can light up the correct game spaces.
Also, not shown in the diagram is the code and case block. The code block interfaces with the microcontroller, where it tells the microcontroller who to send and receive data with and controls the functionality of the checkers game. The case block interfaces with all blocks as it is the enclosure for the entire project and is meant to keep it safe and secure.
Unfortunately, we were unable to complete the functionality of a buzzer block and the game mode switch. But theoretically, the buzzer would trigger a sound if an illegal move was made during the game of checkers, and no sound if the game is played by the rules. It would know when to do this based on the microcontroller sending it a logic high signal to indicate error, or a logic low signal to indicate no error. The game mode switch would have simply altered between the two program modes of play. The game mode switch would have received user input to decide which game is to be played and would then turn on or off the switch based on that input.
And this is a complete overview of our block diagram and how each block interfaces with one another. So, Brandon, what kind of problems did we run into with the printed circuit board for this project?
Well, Shane, what problems did we not come across with the printed circuit board? The complexity of our circuit board is quite big, considering it included the RGB LED grid and also our button grid.
Oh.
And for me it was challenging because it was my first experience designing a PCB.
Yes.
And as many may know or may not know, it's quite challenging getting used to the software and trying to figure out how to route your traces.
Oh, okay.
So first I attempted it using a software known as Eagle that's provided by the school.
Oh, okay.
And I came across the problem of not knowing as an amateur that the school only provided the light version.
So what would that cause?
Well, I come to find out that we could only generate a board that was maybe 1/4 the size of what we needed.
Oh, yeah, that'd be a problem.
Right.
So how did you fix that? How did you get around that?
Well, I decided to go with software known as PCB Web Design.
Okay.
Yeah, it was much more intuitive than Eagle, the functionality of the software, and also I found that it was just quite much easier to use in general.
That's good.
But one of the challenges was that it didn't have directories including components that we were using. So in order to fix that, we both had to manually create each component and look up like the dimensions or the size of how large the holes we needed to make for the components. That was one challenge. Another challenge I'd say is just due to the complexity of the size of the PCB.
Yeah, it's pretty big.
It was, and to see your schematic view go to the physical board view, that just freaked me out. It just looked like a mess of wires everywhere.
Yeah.
Kind of like a spider web.
That would be a problem.
So that was challenging, but we were both able to figure out a pattern that made sense to us and also worked out for our two-layer design. And I think that just going through that struggle helped, or for me, it helped me to get a better feel for how to, I guess, route traces on two layers.
Okay. I think you learned a lot there.
Yeah. So you deal a lot with the microcontrollers. Can you explain like what kind of challenges that we came across?
So there were many, first ranging from the microcontroller itself, not being familiar with it, having to learn what does what and where it goes where.
Right.
And that was the first problem. It wasn't so bad though. Looking at all the data sheets and schematics, you can get it.
Right.
Second problem was that it just stopped working. And like the bad programmers we are, we messed up two of them. So that was pretty bad. But luckily, we were able to get our hands on the third one, and that was fine. We were taught, our teacher and our TAs helped us, and we were on our way.
So I guess you answered my next question. What was the solution? We basically got help from our TAs and fellow classmates, and then we opted to go with a new microcontroller. But it worked out for the best.
It did. And then we had some program issues. Remember those?
Oh, don't remind me, Shane.
What happened there?
Well, as the amateur programmers we were, I'd say it was just really challenging to get used to coding in Atmel Studio. We weren't experienced coders in the C language, and that caused us a lot of trouble.
Yeah. Remember just getting started with the LED grid functionality?
Oh boy, that was tough. I think, but we did solve it. I think the best way to put it is when we were able to draw out the logic behind the code and visualize what was happening, what the code was interpreting. I think that's what really helped us to figure out the problem and to
get the process right.
Right, exactly.
Yeah. And then, what other problems did we run into with just programming?
Besides syntax, having like 25 syntax errors, I'd say the functionality problem that we had was with the mapping of the buttons.
Oh, yeah, that's right. I remember that now. Yeah, that was particularly difficult.
Right, and how were you able to solve that problem?
Since we had the LEDs working, I basically just told it to, if it's all button, at that button turn itself off. And if I could get the first 8, then the rest of the some 24 buttons were the same. So for the first 8, I basically just push button and it should turn itself off. But it would turn like, if I push this button, it would turn like this light off. And that obviously wasn't right. So I'd go through it and turn each one off and then figure out which one goes where. And then I just go back into the code and change its mapping and basically tell it exactly where to look. And that basically solved it. So the next time around, it would turn itself off.
I'm just glad we were able to solve that problem.
Yeah.
It doesn't seem like we had very many challenges, but the time added up, I'd say.
It added up.
But I'm glad we were able to get through it and complete our project.
Yeah, I think we did a good job.
I think so too, Shane.
So, Ren, you want to play a game of checkers?
Sure, sounds like fun. Whoa, so how do I know whose turn it is?
So there's some turn indicators here and here. So right now it's your turn.
Okay, I guess I'll make my move. Here. Now jump you.
Damn. Guess I will.
Here. Oh man. I'm gonna king you, Shane.
Yeah, you have to hold it till the light flashes.
Okay, got it. There I go.
You have a king, and I can jump you, and I can get a king.
Wow. So Shane, what were some group challenges you think that stood out to you this year?
I think our biggest challenge overall was just the loss of our third member.
Right.
They just weren't able to complete their work, and that just ultimately caused them to have to drop the course.
You know, I think that has a lot to do with communication as a group.
That's probably it.
I think it really caused us to fall behind in our work this year.
Yeah. So I guess we could fix that if we just like show each other our work more often.
Mm-hmm.
Like, I mean, like, I don't want to say I don't trust everybody, but bring everyone. Like, you have to show what you've done every week.
Shane, you don't trust me?
I'm not saying I don't trust you.
I'm just kidding.
But yeah, if we show each other what we did every week, then at least we know we're making progress and
Right.
we're making it towards our goal.
Yeah, I mean, for me, I think that, you know, when I was having a hard time with the PCB, letting you know ahead of time that I was having trouble was important to make sure we didn't fall behind in that part of the project.
Yeah, could focus our efforts into
Yeah,
specific areas.
you know, I didn't want to let the team down in that way, and you know, I didn't want it to be because I couldn't, because I didn't tell anyone that I was having trouble. So
that definitely got you on, or finished PCB on time. That was important.
yeah.